All right, in this video, we're going to talk about section 2.5, dealing with basic differentiation properties. And in this section, we're going to be using basic differentiation properties to find the derivative of a function, find equations of tangent lines and values of x for the line tangent to a function is horizontal, and then solve applications involving derivatives. And in this video, this will be the short way of finding derivatives. If you recall, in section 2.4, we were using the definition of a derivative, and it took like 4 steps in order to come up with the derivative of that. In this video, we're going to be learning an easier way and a shorter way of getting derivatives of functions. Now, as you recall in the last video, we defined the derivative of f at x as this. F of x is equal to the limit as h approaches 0 of f of the quantity x plus h minus f of x all divided by h, if that limit exists. Okay. Now, the only notation that we talked about in the last video was this one, f prime of x. There are other notations for the derivatives, so here they are. If you have y equal f of x, then f prime of x, which is also y prime, or this notation dy dx, and that's the derivative of y with respect to x, and the derivative of the function f of x with respect to x. These all represent the derivative of f at x. Okay. So be familiar with these 4 different notations: f prime of x, then y, dy dx, and d of f of x with respect to x. Those are all representative of the derivative of f of x. Now, let's talk about this first case. What is the slope of a constant function? Let's say you have the graph of f of x is equal to c, and c is the constant. As you can see here, this is a horizontal line, and in a horizontal line, if you recall back in college algebra, your slope is always going to be 0. So that means if we know that the first derivative will be the slope of the tangent line, that would mean f prime of x will have to be equal to 0. So here's the first theorem about our differentiation properties here. The constant function rule. If y equals f of x equaling to some constant c, then f prime of x will be equal to 0. Also, y prime will be equal to 0, and dy dx will also be equal to 0. So the derivative of any constant function will be 0. Right? Now, as we're going to see in these examples here, let's say I want to find in part A, f prime of x for f of x is equal to negative 24. So in this case here, f of x is equal to negative 24. If I find out what f prime of x is, and as I mentioned, the derivative of a constant, this is a constant, so the derivative here will be 0. So f prime of x will be 0. And in part B, y prime for y is equal to 12. Here's part B. We have y is equal to 12. So y prime, which is the derivative here of a constant, again, will be 0. Now part C, we have y is equal to negative square root of 7. We want to find dy dx. Well, again, here, negative 7 is a constant. Negative square root of 7 ends up being a constant. So here, its derivative, or dy dx, would be 0. The derivative of y with respect to x would be 0. And also part D. The derivative with respect to x of negative pi. Well, pi is a constant and it's negative, so negative pi has to be a constant. So its derivative with respect to x of that would be also 0. So here, these are just examples of showing you that the derivative of any constant is 0. All right, next is the power rule. The power rule. Okay, here we go. Let's say the function of the form f of x equals to x to the power of n is called a power function. This includes f of x equaling to x, where your n, which will be the exponent for the x, will be 1. And radical functions will be the fractional n. Note that the exponent k does not have to be an integer. It can be an irrational number or a rational number in decimal or fractional form. So here's theorem 2 of the power, which is the power rule. If y is equal to f of x equaling to x to the power of n, and n is a real number, then f prime of x will be equal to n times x to the n minus 1. What that means here is this. When you take its derivative, you're going to bring the exponent in front of the variable, or bring down the power, copy the variable over to the 1 less power. And also y prime is equal to n times x to the n minus 1, and dy dx is n times x to the n minus 1. Now this theorem is going to be very important because as we move along in this course, it's going to be used a lot. So you want to make sure that you bring the power in front, copy the variable over to the 1 less power. So here's some examples of that. Let's say we want to find f prime of x for f of x is equal to x to the 6th power. So I'm going to do part A down here. So here you got f of x is equal to x to the 6th. So to find f prime of x is what we do. We bring this exponent of 6 in front, copy the x over to the 1 less power. So that'll be 6 to the 6 minus 1, which will end up being 6 to the 5th. 6x to the 5th power. So 6x is 6 minus 1, you'll get 6x to the 5th. So that's what f prime of x will be for f of x equal to x to the 6th. 6x minus 5. Part B. Here we're going to find y prime for y is equal to x to the 30th power. Y equal x to the 30th power. So here y prime is this. You bring the exponent of 30 in front, copy over the x to the 30 minus 1, because you want that to the 1 less power. And 30 minus 1 will be 29. So y prime would be 30 times x to the 29th power. Right. Now, part C. We're going to find dy dt for y is equal to t to the negative 2. Y equals t to the negative 2 power. And we want this. We want dy dt. Here's how we do that. We bring that negative 2, which is our power. We bring that in front. So it'll be negative 2. Copy over the t to the 1 less power. So it'll be negative 2 minus 1. And when you do negative 2 minus 1, you're going to get negative 3. So this will be negative 2 times t to the negative 3rd power. That's what dy dt is. Equal to negative 2 t to the negative 3 power. Okay, and I'm not sure how they want that. They probably just want it like that, negative 2 t to the negative 3rd power. because sometimes they want you to give your answer as a positive exponent. But that's fine. All right, part D. The derivative with respect to to x, of x to the 3/2. So to find out what that derivative will be, you're going to bring the exponent of 3/2 in front of the x, copy the x over as I have to the 3/2 minus 1. So this will be 3/2 x to the. Now, if you do 3/2 minus 1, and you can pretty much do this in the calculator, you want that as a fraction. So 3 divided by 2 minus 1, hit the math key, then number 1 for fraction, you'll end up with 1/2. So the derivative of x to the 3/2 power with respect to x would be 3/2 times x to the 1/2 power. Okay. So that's how we apply the power rule for this situation to these problems. Okay. And in some cases, properties of exponents must be used to rewrite an expression before the power rule can be applied. Like in this one, f, we want to find f prime of x for f of x equals to 1 over x. So this is part A. So I'll write down f of x is equal to 1 over x. But in this case, 1 over x, if we write that in its equivalent exponential form, that x has the understood exponent of 1. So if I pull the variable out of the denominator, that exponent of 1 changes to -1. So f of x will be x to the -1 power. Okay. Now, there are some rules that you do need to get familiar with as well. Now, for f prime of x, we're going to apply that power rule by bringing the exponent in front, so it'll be -1, copy the x over to the -1 minus 1 power. And -1 minus 1 would be -2. So it'll be negative x to the -2 power. Now, if they ask you to write that using positive exponents, this will be it. You'll have a -1 in front. The x will have to go in the denominator, and your 2 will be positive. So it'll be -1 over x squared. All right. Now, part B, we want to find y prime for y is equal to the cube root of u squared. So in this case here, we need to write this using exponents. So here that y will be equal to u to the exponent for the u will be your numerator. Your index for that radical will be your denominator. So be y is equal to u to the 2/3 power. And then we can find y prime in this case. So y prime would be to bring the exponent in front. That's your 2/3. Copy the u over to the 2/3 minus 1. This is always going to be to the 1 less power when you take the derivative. 2/3 minus 1, that's what I'm trying to write. So now you got y prime is equal to 2/3 u to the 2/3 minus 1. Using my calculator, 2 divided by 3 minus 1. Math key, number 1 for fraction, -1/3. Okay. And I will leave it like this as an answer. All right, now part C. Let's say we got the derivative with respect to x of 1 over the square root of x. All right, so let's take this one bit at a time here. Let's change the square root of x. in exponential form. We know 1 over. The exponent for the x is a 1, so the 1 will be your numerator. This is the square root, so the index is the understood 2. So here we got 1 over x squared, and we want to find 1 over x to the 1/2, and we want to find its derivative. Well, let's write x to the 1 over x to the 1/2 power using negative exponents. So the derivative with respect to x will be, let's see, x comes out of the denominator, that 1/2 will become negative. So the derivative with respect to x of x to the negative 1/2, we just simply bring the power down in front, the negative 1/2, copy the x over to the negative 1/2 minus 1 power, because it's going to be to the 1 less power. So negative 1/2 times x to the, in this case here, negative 1/2. So it'll be negative 1 divided by 2 minus 1, math key. Number 1 for fraction, it'd be negative 3/2. Okay, and we will leave it like that as well. So the derivative will be negative 1/2 x to the negative 3/2 power. Okay, now let's look at the next theorem. That's the constant multiple property. And it says here, if y is equal to f of x equaling to k times u of x, where k is a real number and u of x is a function, then f prime of x would be this. K times the constant times the derivative of u of x, or u prime of x. And also y prime will be equal to k times u prime, and also dy dx will be equal to k, the constant k, times the derivative of u with respect to x. Okay, that's what the constant multiple property is. Here's some examples of that. In this case here, for part A, we're going to find f prime of x for f of x is equal to 4x to the 5th. So using that constant multiple property, we got f prime of x, that's going to be this. We're going to bring down the 4, and then to take the derivative of x to the 5th, using the power rule, we're going to bring down the exponent of 5, copy the x over to the 1 less power. If you do 5 minus 1, that's going to be 4. Then I can multiply the 4 times 5 to get 20. So it'd be 20 x to the 4th for f prime of x. Okay. All right, part B. Here we got y equal t to the 4th divided by 12. Okay, and if I want to find dy dt, there's like a 1 in front of the t, so this will be like 1 over 12. Then I can take the derivative of t to the 4th by bringing the power in front of the t, in front of that t, that'd be 4. And then the t to the 4 minus 1, which is 3. So I got 1/12 times 4t to the 3rd. And if I simplify 1/12 times 4 over 1, the 4 is gone. 4 goes into 12 3 times. So I'm left with 1/3. So it'd be 1/3 t to the 3rd power. Okay. Now part C. Say I want to find y prime for y is equal to 1 over 3x cubed. And I'm going to write this using negative exponents here. I'm going to keep the 3 in the denominator. So that's going to be 1 over 3, which is 1/3, and pull the x out of the denominator. So the x to the negative 3 power. If I pull that x out of the denominator, that exponent will be negative. And now we can apply that property, that constant multiple property, to find y prime. So here y prime would be this. I'll bring down the 1/3. Take the derivative of x to the negative 3 by bringing down the exponent of negative 3. Copy that x over to the negative 3 minus 1. Think about this. Negative 3 minus 1 would be negative 4. And then simplify this. You can see here that your 3 is going to divide out. You'll have a negative in front. So it'll be y prime equaling to negative x to the negative 4 power. So y prime will be negative x to the negative 4 power. And part D, the derivative with respect to x of 0.9 divided by the cube root of x. First of all, let's change this to an exponent. So in this case here, the derivative with respect to x of, let's see, 0.9 will be in the numerator. The cube root of x in exponential form will be x to the 1/3 power. Okay. And let me make that clear so y'all can see it. Because I know sometimes while writing x and then 1 over 3. All right. But that x to the 1/3 power in the denominator, I can pull that out as this. I have the 0.9, but the x can come out of the denominator, but that 1/3 will have to be negative. So the 0.9 x to the negative 1/3 that we want to take the derivative of with respect to x. Now I can take that derivative by bringing over the 0.9, but for the derivative of x to the 1/3, I'll bring down the negative 1/3 times x. And I'll write this out as negative 1/3 minus 1. And if I simplify, let's see, negative 0.9, well, 0.9 divided by negative 3, or 0.9 times negative 1/3, would end up being negative 0.3. Then copy that x over, and then I have negative 1/3 minus 1 as a fraction. It would be negative 4/3. So that derivative will end up being 0.3, and I left off the negative sign. It should be negative, because 0.9 times negative 1/3 will be negative 0.3 times x to the negative 4/3. Okay. So that's how we use the constant multiple property to find derivatives of functions. All right, theorem 4 deals with the sum and difference properties. If y equal f of x equaling to u plus or minus v of x, where u of x and v of x are functions, then f prime of x will be equal to u prime of x plus or minus v prime of x. And also we can write it as y prime is equal to u prime plus v prime, or we can write it like this: dy dx is equal to du dx plus dv dx. Okay. In other words, the derivative of the sum of two differentiable functions is going to be the sum of its derivatives. And the derivative of the difference of two differentiable functions is the difference of their derivatives, okay? So like in these examples that I have here, so here we're going to start off with part A. We got f of x is equal to 3x to the fourth minus 2x cubed plus x squared minus 5x plus 7. And here I want to find the derivatives of that, derivative of that. So here f of x is equal to 3x to the fourth minus 2x cubed plus x squared minus 5x plus 7. And I want f prime of x. Okay, so here we're going to be using the sum and difference rules by taking the derivative of each and every single term. And some of these will be using the constant multiple property, and some will be using the derivative, the constant function rule. So a combination of those rules will be used here. So if I take the derivative of 3x to the fourth, okay, this is what I'll do. Write down the 3, for x to the fourth, bring down the exponent of 4, and then copy the x over to the 1 less power. So 4 minus 1 would be 3. And then minus 2 times the derivative of x cubed, bring the exponent down to 3, copy the x over to the 1 less power. 3 minus 1 would be 2. Plus, where x squared is derivative, bring the exponent of 2 down, copy the x over to the 1 less power. 2 minus 1 will be 1, but we can leave off the 1, just say 2x minus that 5x. This is like a 1 here, so if I bring the 1 down, that'd be 1 times 5, which will be 5. But that's going to be to the x to the 0 power, which will leave me with just 1. So it'll be 5 here, minus 5. And then the plus 7, the derivative of a constant, is 0. So if I clean this up a bit, this will be 12x cubed minus 6x squared plus 2x minus 5. That is what f prime of x will be. Now, some of these you can just do these simply without including all these steps here. You can just say, bring the power down on the 4 and just multiply by 3 to get the 12. And then copy the x over and get the new exponent to the 1 less power. Part B. We want to find y prime of x. Well, y prime for y equal 3 minus 7x to the negative 2 power. Okay. Because once you get the hang of this, pretty much you can just do it with fewer steps. So y equal 3 minus 7x to the negative 2. I want y prime. Well, the derivative of the constant is 0. Now, the derivative of minus 7x to the negative 2 power. All right, if you bring down the exponent of the negative 2, you're going to have negative 2 times the minus 7, which will give you 14. And then copy the x over to the negative 2 minus 1, minus 3. And you're done with that problem. And then for that x and negative 3, they might want this as 14 divided by x cubed. Okay, they may want it as a positive exponent. All right, part C. Here we got 5. We want to find dy dv for this one. Y is equal to 5v squared minus the 4th root of v. Now let's write this using exponents, because we're going to have to apply the power rule for this. So here, bring down the y is equal to 5v squared minus the 4th root of v that v has the exponent of 1, that will be the numerator. The index is 4, that would be your denominator. So you have y is equal to 5v squared minus v to the 1/4 power. And then we're going to take its derivative. So y prime would be, here if I use the power rule by bringing the power down, 2 times the 5 that's in front, that would be 10. And then copy the v over to the 1 less power, 2 minus 1, that would be 1. And then minus. For v to the 1/4, I bring down the exponent of 1/4. Copy the v over, and then I'm going to do 1/4 minus 1. Okay. So 1/4 minus 1 as a fraction would be negative 3/4. So it'll be v to the negative 3/4 power. Okay. And if they want this as a positive exponent, what you're going to have to do here is bring over the 10v minus the 1 will be in the numerator, your 4 will be in the denominator. That v to the negative 3/4 goes in the denominator as v to the 3/4 power. Okay. Oh, did I copy that problem wrong? That should be 15. That should be 5v cubed. I'm sorry. 5v cubed. And then this will be 5v cubed as well. And then if you take the derivative of that, you copy the exponent or bring down the power. That'd be 3 times the 5, which will actually give you 15. So it's 15 to the 1, v to the 1 less power would be v squared. Okay. And then in this case here, this will be 15 v squared minus 1/4 v to the 3/4. Okay, I apologize for that problem because the example that I did here is not clear. Okay. So I apologize for that. All right, now part D. Here we got the derivative with respect to x of negative 3/4x plus 4/x cubed minus x to the 4th divided by 8. Okay. So in this case here, we're going to take the derivative of each term one by one. But first, let's write using exponents. So I know negative 3/4, that would be negative 3/4. The x is in the denominator, I'll pull that out, and that will be to the negative 1 power plus, and then the 4, that x to the 3rd will come out of the denominator as x to the negative 3 minus, and I'm going to write x to the 4th over 8 as 1/8 times x to the 4th power. All right, so now let's take the derivative. Okay. So for the 3/4 x to the negative 1, I'm going to bring the negative 1 over and multiply that by negative 3/4. That would be a positive 3/4. Copy the x down to the negative 1 minus 1 will be negative 2. And then for the 4x to the negative 3, if I do this negative 3 times the plus 4, that would be minus 12. Copy the x over to the negative 3 minus 1 would be negative 4. And then minus, for the 1/8 x to the 4th, if I take its derivative by bringing the 4 in front of the 1/8, multiply 4 times 1/8, you're going to get actually 4/8, but it'll reduce to 1/2. And you can pretty much do this in the calculator as well. 1 divided by 8 times 4, math key, number 1, you'll get 1/2. And then copy the x over to the 4 minus 1, which will be 3. Okay. Now, if I simplify this a bit with positive exponents, this will have the 3 in the numerator, the 4 remains in the denominator, x to the negative 2 goes down in the denominator as x squared. So I got 3 over 4x squared minus, and then the 12 stays in the numerator, but that x to the negative 4 would go down in the denominator as x to the 4th minus, now I'll put x cubed in the numerator, the 2 remains in the denominator. So this will be 3 over 4x squared minus 12 over x to the 4th minus x cubed over 2 as a derivative of that function with respect to x. Okay. Now here's some more examples about rewriting before differentiating. Okay, so this one is a little bit different. Here, we want to find the derivative with respect to x of 10x plus 11 over x. So this is what I will do here. The derivative with respect to x. Now I'll write this as this. Each of these is over x, so I will write this as 10x divided by x plus 11 over x. Then simplify this. Derivative with respect to x, well, 10x divided by x would just be 10. Now I'm going to write 11 over x using negative exponents as 11 x to the negative 1 power. And now let's take its derivative. Okay. The derivative of a constant is 0. The derivative of 11 x to the negative 1, if I bring this exponent down, negative 1 times 11 will be negative 11, and then x to the negative 1 minus 1 will be negative 2. And I can write this as negative 11 in the numerator, and then x squared will be in the denominator as x to the positive 2. And keep in mind, the derivative of 10, the derivative of any constant is 0. Keep that in mind. Okay, here's another example. F prime of x is what we're trying to find if f of x is equal to 5x plus 7 quantity square. Now, there's a rule that we're going to talk about in another video, but since we're only dealing with these properties of differentiation, what we're going to do here is expand this out and then take its derivative. Notice that 5x plus 7 is used as a factor twice. So I'm going to write this as 5x plus 7 times 5x plus 7. And now let's simplify this using the FOIL method. 5x times 5x is 25x squared. The outer 5x times 7 will be plus 35x. The inside 7 times 5x will be plus 35x. And then 7 times 7 will be plus 49. So here f of x will be equal to 25x squared. 35x plus 35x plus another 35x will be plus 70x, and then plus 49. So that's what f of x is. 25x squared plus 70x plus 49. Expanded, by the way. Now we can take its derivative. F prime of x will be this. Bring this exponent down. Take that 2 multiplied by 25, you'll get 50. Copy the x over to the 1 less power. it'd be x to the 1 plus derivative of 70x. Well, the derivative of just a linear term would be the constant itself. It'd be plus 70. And the derivative of the constant is 0. So f prime of x will be equal to 50x plus 70. Okay. All right, here's another example. So we have something like this, dy dx. We want to find that if y is equal to 3x minus 9 divided by 27x to the 5th power. All right, so let's simplify this a bit. Each of these terms can be divided by 27x to the 5th. So I'll have 3x over 27x to the 5th minus 9 divided by 27x to the 5th. So for the 3x over 27x to the 5th, let's see, if we reduce 3 over 27, 3 goes into itself 1 time, 3 goes into 27 9 times. I will have this. Let's see, this x can be reduced. I can cancel or divide out an x with an x to the 5th. That would give me x to the 4th. X to the 4th. So that means I will end up with 1 over 9x to the 4th minus the 9 over 27. 9 goes into itself 1 time. 9 goes into 27 3 times. So this will be 1 over 3x to the 5th. And then using negative exponents here, this will be 1 over 9. And if I pull the x out of the denominator, it will become a negative 4 minus, I have 1/3. If I pull the x to the 5th out, it will be x to the negative 5th. Okay, so I'm writing this using negative exponents because I'm going to apply the power rule for each one of these to come up with dy dx. All right, so if I do negative 4 times that 1/9, that would be a negative 4/9. Copy the x over to the negative 4 minus 1, which will be negative 5. And then if I do negative 5 times the minus 1/3, that would be a plus 5/3. Copy the x over to the negative 5 minus 1, negative 6. Sometimes they may ask this, they may want this for an answer. Negative 4 over 9, and then the x to the 5th will be in the denominator with a positive exponent. And then the 5, the 3 remains in the denominator. X to the negative 6 goes down in the denominator as x to the 6th. Okay. They may ask for this form or this one. Okay. So that's some more things about rewriting before differentiating. And you might have to do just that. All right, now let's look at some applications to finding the derivative. Okay, and these are quite familiar, but we're going to do them a shorter way, using these quick ways of finding the derivative. Remember that the derivative gives the instantaneous rate of change of the function with respect to x. That might be instantaneous velocity. It could be the tangent line slope at a point on the curve of the function. Also could be marginal cost, where if c is the cost function, that is the total cost of producing x items, then c prime of x approximates the cost of producing one more item at a production level of x items. So we call c prime of x the marginal cost. Okay. And we're going to be talking more about that in section 2.7. when we look at marginal cost. All right, so here's an example of an application problem. This deals with a object. Let me get this paper up here. Here we go. The object moving along the y-axis marked in feet so that its position at time x in seconds is given by the function f of x is equal to x cubed minus 12x squared plus 45x. So in part A, we're going to find the instantaneous velocity function, which is v equaling to f prime of x. And then you're going to find the velocity when x is equal to 1. Part C, you're going to find the time or the times when your velocity is 0. Okay. So in part A, here's our function. F of x is equal to x cubed minus 12x squared plus 45x. Now we want the instantaneous velocity function, which is, of course, v is equal to f prime of x. So here, we're going to use those properties that we just got through talking about to find this derivative. This one, we're going to apply the power rule by bringing the exponent in front. So it'll be 3, copy the x over to the 1 less power. 3 minus 1 is 2. And then minus, bring this exponent of 2 in front of the 12, multiplied by 2. 12 times 2 will be 24. Copy the x over to the 1 less power. 2 minus 1 would just be the understood 1. And for 45x, its derivative would just be the constant itself, 45. So here, your velocity function is going to be 3x squared minus 24x plus 45. So that's part A. Part B is to find the velocity when x is equal to 1. So when x is equal to 1, f prime of 1, we're just going to substitute the x in our f prime of x function with 1. So it'll be 3 times 1 squared minus 24 times x, which is 1, plus 45. Well, 1 squared will be 1 times the 3 in front will be 3, minus 24 times 1 will be 24, plus 45. 3 minus 24 will be negative 21. Negative 21 plus 45 will be 24. And this will be in feet per second, since velocity is in feet per second. And we're dealing with feet in seconds. So when x is equal to 1, the velocity will be 24 feet per second. Or the velocity of the object moving along the y-axis will be 24 feet per second. We'll have that velocity. All right, part C. Find the time or the times when your velocity is equal to 0. So in other words, we want to know what's the time when v is equal to 0. And this is our velocity function, 3x squared minus 24x plus 45. We're going to take that, set it equal to 0. Okay. Now we're going to factor this completely. And in this case here, we do have a common factor of 3. So we're going to factor out the 3. We're going to have 3x squared divided by 3 will be x squared. Minus 24x divided by 3 will be minus 8x. 45 divided by 3 will be plus 15, equal to 0. Now let's factor x squared minus 8x plus 15 completely. Bring down to 3. X breaks up as x times x. The middle term is a minus and the last term is a plus, so they both have to be minus. Factors of 15 that will give me 8x as a middle term will have to be 5 and 3. Because negative 5x minus 3x will give me negative 8x. So I had 3 times x minus 5 times x minus 3 is equal to 0. Then we set each factor equal to 0. So I set 3 equal to 0, set x minus 5 to be equal to 0, and x minus 3 to be equal to 0. Well, 3 equaling to 0 is not true, so we cross that out. For x minus 5 equal to 0, if you add 5, you're going to get x is equal to 5. And then for x minus 3 equals 0, if you add 3, you're going to get x equals to 3. So when your velocity is 0, you're going to have the time being at x equals 5 seconds and x equals 3 seconds. Those are the times when your velocity is equal to 0, 5 seconds and 3 seconds. Okay. Got 2 left in this video. Let's look at this example. A person, x inches tall, has a pulse rate of y beats per minute as given approximately by y equal 591 x to the negative 1/3. For x is between 30 and 75. And here we want to find the instantaneous rate of change of pulse rate for the following heights, A being 41 inches and B being 59 inches. Well, first of all, we need to find the derivative of this function. So here we got y is equal to 591 x to the negative 1/3. Now let's take its derivative, which is going to be y prime. So here we bring this exponent of a negative 1/3 down. Well, let me go ahead and write it out. Bring down the 591 and then bring down the exponent of negative 1/3. Copy the x over to the negative 1/3 minus 1 power. That's going to be negative 4/3. Okay. And in fact, I did a problem just like that where I did this on the calculator. So again, 1 divided by 3 minus 1, math. Number 1 for fraction. I'm sorry, negative 1/3. Negative 1 divided by 3 minus 1, math, then 1, negative 4/3. That's that exponent. Now, if I simplify this, negative 591 divided by negative 3 would be negative 197. And then x to the negative 4/3. Okay. So let's use that to answer parts A and B. The instantaneous rate of change for the following heights for 41 inches. So here, x will be 41 inches. So here, y prime at x equals 41 would be negative 197 times 41 to the negative 4/3 power. And I'm going to show you how that's into the calculator. Negative 197 times 41. Hit your hat key for the exponent, and then the negative key, and then 4 divided by 3. And then hit enter. Let's say I want to round this off to 2 decimal places. So this will be approximately negative 1.39. Okay. So the instantaneous rate of change of pulse rate would be negative 1.39 for someone whose height is 41 inches. And then part B would be 59 inches. So x is going to be 59 this time. And then we just use that derivative function, y prime, and just substitute the x with 59. So it'll be negative 197 times 59 to the negative 4/3 power. So y prime would be, in this case here, negative 197 times 59. Press the hat key for your exponent. Negative 4 divided by 3. To 2 decimal places, this will be approximately negative 0.86. Okay, so that's your instantaneous rate of change, a pulse rate for someone who's 59 inches tall. Okay. And finally, the total sales of a company in millions of dollars T months from now are given by this. S of T is equal to 0.03 T cubed plus 0.5 T squared plus 3T plus 4. And we're going to find S prime of T, that's part A. Part B, find S of 5 and S prime of 5 to 2 decimal places. And part C, interpret S of T equaling to 114 and S prime of T equaling to 22. Okay. So let's find S prime of T. Well, let me write S of T first. That's 0.03 T cubed plus 0.5 T squared. Plus 3T plus 4. Now we can find the derivative of that by doing this. For this term, multiply that 3 times the 0.03, you'll get 0.09. Copy the T over to the 1 less power. It'll be T squared. Plus, this one, we bring the 2 down, multiply 2 times 0.5, that would be a 1. So it'll be 1T or just T to the first power, because that's to the 1 less power, plus derivative of 3T is just going to be 3. The derivative of a constant is 0. So S prime of T will end up being 0.09 T squared plus T plus 3. Now part B is to find S of 5 and S prime of 5 to 2 decimal places. Well, using the original function, we're going to find S of 5. So that's 0.03 times T, which is 5, and that's going to be cubed, plus 0.5 times T, which is 5, plus 3 times T, which is 5, plus 4. And I'll do each one of these individually, if it helps. 0.03 times 5, and then that's going to be cubed. That would be 3.75. And then plus 0.5 times 5, that would be, oh, I'm sorry, this should be squared. I'll let that out. Yeah. 0.5 times 5, and then you square it, would be 12.5. And then plus 3 times 5, that would be 15, plus 4. So we add 3.75 to 12.5 to 15 and to 4, you get 35.25. So S of 5 will be 35.25. And that represents the total sales of a company in millions of dollars. S prime of 5, this time we use the function S prime of T. That's this one right here. And substitute our T with 5. So it'll be 0.09 times T, which is 5. And that's going to be squared, plus T, again, that'll be 5, plus 3. 5 squared will be 25. 25 times 0.09 will be 2.25 plus 5 plus 3. 2.25 plus 5 plus 3 would end up being 10.25. So in this case here, that S prime of t will just be the instantaneous rate of sales. Now, part C, they want you to interpret S of t equal to 114.00 and S prime of t equaling to 22. So here we go. What S of t, S of 10 equaling to 114.00, it means this. It represents the total sales ten months from now. And it would be that amount, $114.00 million. Because the sales is going to be in millions of dollars, as indicated in the problem. Okay. And then for S prime of t equaling to 22.00. Now, since we're dealing with the instantaneous rate of change, that's the first derivative. That's saying this: in 10 months, the sales will be increasing at a rate of 22, and I think this is in millions of dollars, since that's what they're talking about here, $22 million per month. Just per month. Okay. So that's how we interpret S of 10 being 114 and S prime of 10 being 22. Okay. All right, so I got one more example. And here it is. This deals with the tangent line in this case. So that's for the function f of x is equal to 2x to the fourth minus 8x cubed plus 5, we're going to do the following. We're first going to find f prime of x, and then we're going to find the slope of the graph of f at x is equal to 1. Then we're going to find the equation of the tangent line at x is equal to 1. And then finally, we'll find the values of x where the tangent line is horizontal. In other words, the slope has to be 0. So let's find out what f prime of x is. So here, f of x is equal to 2x to the fourth minus 8x cubed plus 5. And if I take its derivative, here, bring the 4 down, multiplied by 2 will be 8. Copy the x over to the 1 less power. It'd be x cubed. And then minus, bring the 3 down, multiplied by 8, you'll get the 24. X to the 1 less power. 3 minus 1 will be 2. The derivative of that constant will be 0. So f prime of x will be equal to 8x cubed minus 24x squared. That's part A right there, just finding f prime of x. Now, part B is to find the slope of the graph of that function at x is equal to 1. I mean, -1. So at x equal -1, we just substitute our x in the f prime of x function with -1. So here we're going to have h times -1, that's cubed, minus 24 times x, which is -1, and that will be squared. Well, if I cube a negative, that's going to be negative. So -1 cubed would be -1 times the 8 in front will be -8. All right, minus the -1 you square is going to be positive. So it'll be minus 24. -8 minus 24 ends up being -32. That represents the slope of the tangent line at x is equal to 1. I mean, -1. So this is the slope. Let me move this up. Of the tangent line at x equal -1. That's the slope of the tangent line at x equal -1. That's part B. Part C, we want the equation of the tangent line. All right. I already know what the slope is, but let's find out what my point is at x equal -1 using the original function. F of x equal to 2x to the fourth minus 8x cubed plus 5. Well, in this case here, at x equal -1, f of -1 will be 2 times -1 to the fourth minus 8 times -1, and that's cube plus 5. Well, a negative to an even power would be positive. So -1 to the fourth will be positive 1 times the 2 in front will be 2. -1 to an odd power will be negative. So -1 cubed will be -1 times the minus 8 will be plus 8 plus 5. So here 2 plus 8 will be 10. 10 plus 5 will be 15. So here I have a slope of -32. The ordered pair that I'm going to be dealing with is -1, 15. Then we use the point slope form for the equation of this line. And that point slope form would be y minus y1 is equal to the slope m times x minus x1. And if you recall, your x1 would be -1, y1 would be 15, m is -32, so we just substitute in the point slope form. So this will be y minus y1, which is 15, is equal to your slope m, -32, times x minus x1, which is -1. Well, x minus a -1 would be x plus 1, so I'll have y minus 15 is equal to -32 times x plus 1. And then next, we'll distribute on the right side, so dy minus 15 is equal to -32x minus 32. Add 15 to both sides. So that means y is equal to -32x minus 17. So this represents the slope of the equation of the tangent line at x equals -1. It'll be y equal -32x minus 17. And then finally, part D, we want the values of x where the tangent line is horizontal. Okay. So here we're looking for a horizontal line. And if you recall, when you have a horizontal line, that means that your slope will be 0. Anytime you have a horizontal line, that means the slope of that horizontal line is automatically going to be 0. And f prime of x has to be equal to 0 because that first derivative will give you the slope of that tangent line. And f prime of x we found in part A was this 8x cubed minus 24x squared. So we're going to have 8x cubed minus 24x. We're going to set that to be equal to 0. Now let's do some factoring on the left-hand side. Common factor there is 8 and x. And that should be 24x squared. So it'd be 8x squared. Okay, so let me correct that. So it's 8x cubed minus 24x squared equal to 0. That was our f prime of x. And if you factor out the 8x squared, 8x cubed divided by 8x squared would leave you with x, minus 24x squared divided by 8x squared would be 3. That would be equal to 0. Then we set each factor equal to 0 and solve for x. So this means 8x squared is equal to 0. X minus 3 is equal to 0. Well, for 8x squared equal to 0, if I divide by 8, that will be x squared is equal to 0. The only number squared that would give me 0 is 0. So x has to be equal to 0. And now for the x minus 3 equal to 0, if I add 3 to both sides, you'll get x is equal to 3. Okay, so to answer that question, the values of x where the tangent line is going to be horizontal will be at x equals 0 and x is equal to 3. Okay. Okay, so that does conclude this video on section 2.5 dealing with the basic differentiation properties. All right, feel free to email me or contact me in any way if you have any questions about any of the examples that were presented in this video, or if you have questions about the homework in my math lab.